Hi guys, welcome back to channel. In this video, we are going to build end-to-end our computer vision apps for our brain tumor detection app. So this is the UI, simple UI that we are going to build, and you can find all the code in my GitHub repo. I will mention the GitHub link in description. So let's look at workflow of this app. So this is the entire workflow of this app. First of all, we will obtain our dataset for brain tumor detection from RoboFlow. For those who are new, RoboFlow is an open source platform which is top company in the computer vision to provide computer vision datasets. And to, to train this data, we are going to use YOLOv8 model, which is highly accurate and more speed compared to any other models of YOLO version, and then optimize this model for mobile apps, and then convert it to TFT Lite to integrate in our app that we are going to build in Android Studio. Then set up the Android Studio, writing the code to our UI that I just shared here. This is the simple UI. We will upgrade in the next video to enhance this, and then integrating our exported TF Lite model into our app through Android Studio, and then add the code to type bounding box, and then test it and deploy it in the app. So this is the workflow. First we will obtain the dataset, then train it and optimize it. And this is the workflow for our app. Set up the Android Studio, writing the UI code, integrating our exported model into app, then write the detection code. Note that if you are using any Flutter or Java or something else for writing your apps, you have to write some custom code to detect plot the bounding box on the image, uh, and then test it and deploy it. So first of all, let's look how we can obtain the dataset that we are going to use, and how to train the model. So this is a notebook. I am using official Overflow notebook to train the model, and let's first obtain our dataset. So we are going to copy this, and so we are going to use this dataset from RoboFlow. I will link the comment in the description. So it's just have total to 20 2000 2870 images for different classes. We can check the classes here. It's almost five classes. We will skip this one and capture the remaining one. So all you have to do is that go to your dataset and click on the dataset link, check the show code, and then select the YOLOv8 format, and then continue. This will give you a notebook link. You just have to copy this and move to our main file. So first of all, make sure you have the runtime to T4 GPU or TPU to run this file. First of all, these are the instructions to run the code. Uh, this command is make sure to that we are using our GPU. Then we are going to set up our home for easy integration or capturing the variables. Then we are going to install our libraries like Ultralytics and check its versions. You can also clone it through GitHub, and we are going to import some libraries like image, display, and the YOLO from Ultralytics. And let's test some CLI. Uh, let's test the YOLOv8 small version through CLI command on some random image. So we are going to use our home variable that we just defined here, and the task is to detect. We are going to just detect the entities or test this model on a detect task, and the mode is to pretty. The model was YOLOv8 7, and the confidence interval is 0.25, and the source image is just we just put the source image URL, and save is equal to save this result into our memory, and these are just classes that just detected. And you can also test this same. uh, so here is the result. We are just displaying our result here through this code. So these are the classes that are just go detected, like dog, person, bag. Similarly, you can also show this through this SDK command, but this week. So here is the tensors that just go detected for this bounding box. Now the next step is to prepare our dataset and do some training stuff. So for that video, we are just using this code that we just copy, and the the data set already prepared. You can see that data set is already separated. Pre-processing are applied, auto orientation, the size, gauge scale applied, and augmentation also applied there. So you don't have to worry about the pre-processing steps of augmentation and other stuff. So the data is already here. You can also switch to version that you would like to use, and then just paste here. Make sure you do not reveal your API while sharing this. So you will get your API through this code once you click this. Okay. This is your API. You can't reveal this to open anyone. Uh, we are making the directory by the name of dataset, and then installing the RoboFlow. Uh, Download this data and importing the RoboFlow by, and then using our API key, we are making it we are initialize it, and then uh, this code we are just picking this dataset and the project name and the version that we are going to use this dataset. Like this dataset has 6 version, and we are using the 6th version dataset, and yeah, to YOLOv8 according to YOLOv8 format, and we just set up our dataset, and let's do the custom training on our dataset according to our requirement or whatever you want to do. So This is a CLI command that will run and train our data. So the YOLO and the task is to detect. Then the mode have to training mode, as we are going to train this model on our custom dataset, and then we are using YOLOv8 7 YOLOv8 smart version of this model. In the location of the dataset that we just define here, the directory and the YAML file. So for now I just keep it to 50 epochs, and the image size is 800 pixel, and plot is equal to 2 mean that we are we want to see this result every epochs. So after running this command, you will be able to see uh, these training epochs. So I just run into 50 up to 50 epochs. So after running this, you can find the result here. Yeah, the class's name, image, instance, box precision, and similarly mean average 15, and the mean average precision 50 to 95. So you can see that all the classes have almost load 68 63%, and but per individual you can check for each class here. So you can enhance it by training the more epochs, and then just displaying some graph that we are just got. So in the home page, the page, there after running this code, you will get a directory by the name of runs, and inside its detect and train folder, and train folder you will get some graphs. And let's display the confusion matrix. So confusion matrix is used for to classify how much your classes should be able to classify accurately. So you can see that uh, gli- glioma, tumor, code 131, and similarly other ones you can read it. Uh, yeah, you can read it. And for next, let's display some other metrics as well. So this is a confusion matrix, and this is normalized confusion matrix. And let's display some result that we just go detective, and inside run folder, um, inside run folder we have detected train form and batch. So these are the images that just try to validate them or displaying them. So these are the images, and let's validate this custom model on a random data set. So inside home, we are using YOLO. Task is to detect, and the mode for now the mode is validate. First we have used the training mode. Now we are using the validation mode, and we got our best model here. After training the epochs, 50 epochs, you will get your two model. One is last model, and one is best model. Best model means that the performance where the model perform well according to the epochs and the dataset locations. We are doing setup here and the YAML file. So the validation score is almost the same, as you can see there. This one and this one. So the model performing good. And for, next, let's do some inference or predictions. So we just changing the mode here to predict, and using our best model that we just got after training, and set up the some inference, confidence interval and the data set. Now for running the inference, we are using the test images. Uh, we are using these images and saving it after running the inference to show some result. And these are some result. You can display all the images using this command. these are some cool results. And next, we just importing our model to TF file that you can see the optimize and converting the PyTorch model that we just got by the name of best pyt. So we're just importing it to TF file to use in our Android app. So after running this command, you will get your TFT Lite model. So you can download it and keep saving your directory. So these are the code that we just use for training our data on the YOLOv8 model of brain tumor detection. So